Now, hopefully you've got your head around trying to factorise a trinomial. Now, let's have a look at looking at some harder ones, which we call non-monic trinomials. Now, the idea it's a non-monic trinomial means that we've got another number there. So, a monic means it's 1 in front. So, these are all non-monic because there's a number in front of x squared, which is the largest term. We call that the degree. So the degree is of 2. So the leading term has the highest degree there. So what we want to do is factorise this one, and we're going to go along the same lines. So we've got to look at what two numbers. We know it's going to come into 2 brackets each time. If it's going to be factorising a trinomial, it's going to come down to 2 brackets. And the 2 brackets that it's going to come down to, this term has to be multiplied by the first 2. And this term multiplies by the multiplication of the second 2. And then the combination of when we cross over and do the multiplication there will give us the middle term. So there's what we're going to look at. Now, the nice thing about some of these questions, and especially this question, is that 2 is a prime number and so is 3. The more prime numbers you have, the easier it is, because we look at something like 12 or 24 or numbers like that there or in front, they start to have more factors. The more factors you have, the more sifting through you have to do to pick which ones are going to work. But when they're prime numbers, well, if they're going to work out nicely, and which these questions will generally do because that's what they're aiming to do, then the numbers they pick will be nice, will be much nicer. So here, we know it's going to be 2x and x. Because 2x squared is 2x times x. Doesn't come out any other way. So the idea is to be, okay, if I've got 2x and x there, what 2 numbers multiply to give me positive 3? Not too bad, because I know that's positive, so the 2 numbers are going to be positive. And so I'm looking at 1 and 3. So that's okay. Now the problem is, okay, if I put a 1 there, say, and a 3 there, is that going to give me 5 when I cross them over and multiply? So, because that gives me positive 3, that gives me 2x squared. So there's my first and last terms in the expression. But can I when I multiply the 2x by this number, if that's going to be 3 over here and that's going to be 1, is that going to work for me? So 2x times 1 would give me 2x, and 3 times x gives me 3x. So that gives me 5x. Very nice. Sorry, well, no, that didn't work for me. That gave me x times. I'm supposed to multiply this way. Let's get it right. So we've messed that up a bit. So let's clear it up and be really careful with what we're doing, because we're going to have x times 1 gives me x, and 2x times 3 gives me 6x. So let's not make that mistake, which is going to give us 7x, which is not the 5x we want. So that's the problem. This then doesn't work, so we need to get rid of it and try the other combination. And the good thing about this one is there's only 2 combinations. So it's either 2x with the 1 there, or the 2x with the 3 up here, and with the 1 there. So now let's try it. X times 3 gives us 3x. 2x times 1 gives us 2x. Now they add to give us the 5x. And we're in business, because that's the 2 numbers that multiply to give us and add to give us the 5x there, which is what we need. So there's our term. So that means we put our brackets around, and 2x plus 3, x plus 1. And that's how we go about doing those. So in 2 here, again, I'm going to have 3x and x. And what 2 numbers multiply to give us minus 2? Well, it's going to be 2 and minus 1. Now, the thing is that one's going to be positive, one's going to be negative. If I put a minus 2 in there, and I put the 1 there, I know that's going to give us a minus 2. I know that's giving me 3x squared, so we're okay there. But that's going to give us, when we multiply it out, minus 2x. That gives us 3x, which when I do the addition, is going to give us a positive x. That's not good enough. I need 5x. I need the other combination, so I need to swap them around. Now, this time there's 4 different ways we can go about it, because I can change the signs on it. So if I put a 1 there and put the 2 there, and let's make it minus there, that would give us minus 6. x, and that would give us a positive x. That gives us minus 5x. Well, that's a little bit better, but I've got the wrong sign. So if I change the sign there, that might help me, because if I put it as a 3x with a minus 1 there, because minus 1 times 2, that will give us a minus x. That gives us a positive 6x. We add those together, now we get our positive 5x that we wanted. So it's trial and error is going to take place. So, and that's okay. As I said, the more you do, the better you get at this. The better you get at going, okay, I know this one's going to be these. There's going to be a good chance of being these two numbers, and this one's going to be negative. I don't get them right every time first go, but I'm able to check and make sure I'm right, because I know once I've got it in this situation, I can expand it back, and I need to get back to this number. So that's not too much of a problem. So you can always play around with the numbers, but again, it's the process. If you can get the process right, then you will go through and you'll be able to get all these. Okay, so keep that in mind. You need to go back and have a look at the process we're doing there. Again, if you you've learned a different way and you're quite happy with a different way, and you can solve these and factorize these trinomials, then go for it. As I said, this is not the only way to do it. I like this one the best, and that's the way I will teach it all the time. But again, I want you to get the right answer, not to necessarily have a particular method in mind to solve it. So if you're solving it correctly, you can do these without what I call the cross method. That's fine. So you can go to the next one and do the next questions as well. Stop the video, have a go, and then come and check your answers. But I'm going to go through, and I'll put them there so you can stop and have a look. And we want to have a look now at using identities to factorize. So again, if I can reverse these at any stage, then I'm going to try and do that. If I can pick them up and see those, then really try and have these in your mind to be able to go back and factorize easily. Again, it comes with experience. The more you practice, the better you get at it. But and you've got to go and practice. You're going to do questions in class. You're going to do questions at home. You've just got to practice. The more you do, the better you get. And if you can pick up these and see these and be able to work in that direction, makes life easier. It's easy as well if you work in that direction when you've got to expand them. But if you can recognize that this is going to give you the perfect square, then that's going to make life easier. And we will have to do this. We will want to get perfect squares in some of the things we do to solve and get that factorization happening. Ones that you don't do in the junior course, we do in the senior course, is the sum and difference of cubes. So if we have a cubed plus b cubed, there's our factorization. Now notice the factorization there is pretty close to what we've got here. So it's an a mod plus b in that small bracket, a squared minus ab plus b squared. Now that doesn't factorize down to anything. And it looks close, and you're looking maybe going, oh, wait on, but I really need a 2ab, but it's not a 2ab when we factorize this one. And a cubed minus b cubed, the only difference between the first one and the second one is that the small bracket would have a minus there, and the ab has a positive. So the signs change in the factorization. So really it's just a minor variation in what you need to do there. So if you're not sure, well, wait on, does that really work? Expand this out. A times the a squared times that one, and then plus b times a squared times that one times that, and collect all your terms. All the terms will cancel down. You'll end up with an a cubed plus a b cubed. And the same thing here if you expand that out. So again, these are ones you need to be able to learn off by heart. And if you see the expansion there, the expression there, you're able to factorize a cubic. And we don't go any higher than cubics. If it's a power of 4, then we're going to be breaking it down to using other techniques to solve that. But that's what we're looking at here. For the x cubed plus 27, that comes down to an x plus 3 because they're the cube roots of each of those. Positive there, so it's positive there. So it would be x squared plus the 9 and be a minus there, and it's just the multiplication of those two terms. And that's what you'll notice, all that. Square root, cube root. Negative, negative, that's going to be positive. So the signs there are different. It's always a plus b squared. So the last term would always be the b squared, so the cube root of that, and then square it. So whatever that term is, square that. So here it doesn't matter whether it's number in front or the y cube. Remember, 1's a perfect cube as well, so it's cube root of 1 is 1. So we get that factorization happening there. So there's some more types of factorization. Getting harder, that's the nature of it. It doesn't get too much harder than this though with your factorizations. That's as hard as it probably gets. We're just going to have more terms and be able to manipulate our terms as we go along. So we'll look at in the next video at some problems where we start to bring it all in, and we'll try and come up with ways to look at an expression and try and pick, okay, which one am I going to do and which method am I trying to pick up straight away.